Thank you, Jim. This afternoon, I'll give you a quick overview of PDI and AgCross. To me, the number one question for any project is who are the stakeholders? Who are the customers? To me, the PDI target customers are clear. Our number one customer is our in-house research teams. Our number two target customers are collaborators. Nearly all of our ARS research units work with collaborators. So if the PDI solutions do not work for these collaborators, then these solutions do not work for our ARS researchers. Number three are our stakeholders, our customers, linked to our various research units. And finally, ARS and USDA administration. PDI is focused on improving the efficiencies of how we conduct day-to-day research activities with regards to data. Unfortunately, I don't have enough time to dive deep into the schematic, so I'll discuss it at a high level. Items in the green boxes represent data management solutions that PDI is actively working on today. These include expansion of the AgCross data platform, developing linkages to external data platforms such as Ag Data Commons, NOAA, USGS, and others, developing customized data collection apps for observational data, evaluating connectivity solutions to improve the transmission of data from field to the cloud, developing linkages between continuous monitoring systems and AgCross, developing optimized regional laboratories for common sample analysis. The boxes in the red are things to come. We will likely start on some of these in 2020. The Decision Support Informatics Platform, or DSI platform, is something that I'm excited about, and I'll touch on briefly in a few minutes. An example of a PDI data management solution is this Balance software. It was developed by our PDI tech team and is currently being rolled out. This type of software is commercially available. However, when I solicited quotes, the cost was about $930 per balance. This commercial software is not a cost-effective solution, since I wanted to roll something out across ARS. So we developed an in-house solution. With this software, we can weigh samples 15 times faster than our common paper and pencil method. Plus, there is no data entry, thus reducing the potential data errors. Jose will provide some additional details in session 4 on the Balance software. We are developing a PDI regional manure plant, soil, and water laboratory at University Park, Pennsylvania. ARS has made a large investment in this laboratory to optimize the sample analysis process by eliminating equipment bottlenecks, minimizing sample handling, and developing software to minimize data touches. Our goals are to increase the capacity at this laboratory by about tenfold. When fully operational, this laboratory will be a huge resource for the LTAR network and others within ARS seeking common manure, plant, soil, and water analysis. Kyle will talk more about the regional lab in session 4. We are developing customized tools to capture field management data. This data is stored on the cloud and available to local users with permissions. PDI has developed a custom app for citrus production, which will be discussed by Kristen Carlson in session 4. We are also developing a customized field collection app for BARC, or the Beltsville Agricultural Research Center here in Beltsville, Maryland. Dan Roberts will cover this briefly in session 4. Next, I'll show you a quick video of the Citrus app. Through this video, I hope to give you a quick feel for the data input apps that PDI is developing. They are customized apps for targeted end user groups. For this specific app, the target end users are citrus producers and APHIS personnel. The PDI tech team worked with the end users to develop a list of field management data that was to be collected and then developed a draft data flow layout. The tech team developed a beta version of the app, which was used in a follow-up discussion with the end users. Then the end users and the tech team had weekly calls to fine-tune the app. Once the end users were happy with the app, it was published and ready for use. Typically, this process takes a month to 3 months depending on the end user group. In this video, we are going through the AgCross interface to a specific research project in Beltsville, Maryland. In this project, we are overlaying Venus Satellite, AgVoice, unmanned ground vehicle, and continuous monitoring data. Here we are going to zoom into the scientist observational data collected through the AgVoice technology. Now we are looking at some real-time soil moisture data being relayed through Microsoft FarmBeats platform. We also provide the ability to bring the data from equipment-mounted sensors. All of this information is brought into a geospatial platform in separate data layers. Using the AgCross platform, we link to external sources such as Venus satellite data, where we are overlaying Venus NDVI data. PDI's role in this process was to help the scientists develop the data management solutions to standardize, integrate, and automate their data collection so they could focus on refining the machine learning models and their other science objectives. AgCross is a data hub designed to eliminate data silos. It provides researchers an environment for sharing data and science and engaging their stakeholders. It maintains a project's unique identity while engaging other projects in what we call a network of networks. In this video, we are drilling down into a specific long-term project in Colorado. Using the query tool, we can search for data on specific grasses for a specific measurement parameter. Here we're selecting a series of 5 different grasses for this research area or study. In this graph, we can quickly see the above ground biomass levels for selected groups over a 30-year period. We see AgCross as a one-stop shop for agricultural data. We aim to achieve this by linking to external data sources and creating a user-friendly environment so our scientists can more rapidly obtain the data for their research needs. Here we are looking at stream gauge data from USGS and NOAA. We have Microsoft TV Whitespace technology installed at our Beltsville, Maryland location. Our current goals are to conduct a spectrum evaluation at 5 additional ARS sites, hopefully later this summer. Once we have this information, we will be working with Microsoft and Verizon to develop concepts to solve some of our data communication issues. This slide is messy, but I wanted to make the point that our ARS researchers develop a large number of models, decision support tools, outreach materials, and other products. The challenge is that it can be extremely difficult for our stakeholders to find these outstanding resources. The goal of the Decision Support Informatics Platform, or DSI, is to create a one-stop shop for stakeholders to find our researchers and the incredible products they are developing. This will not be an easy task. We will lean heavily on our private partners such as Esri and Microsoft to help us develop these customized solutions. Sherry Hunt will also talk about the PDI DSI in session 4. The PDI organizational structure is broken down into 5 major components. First, we have the PDI board, and I will introduce them shortly. All data project and data management tasks will be evaluated by the board. If approved, the board will assign a task bucket and a priority rating for submitting the task to the PDI technology team. So what are the task buckets? The task buckets are aligning and integrating historical or legacy data, working with continuous monitoring systems, developing observational data input apps, developing data dashboards, and other. The other task bucket could include things like customized software solutions to automate data collection, like the Balance software, or could be developing specific APIs. Next, we have project coordinators. These coordinators work directly with researchers. For example, Greg Wilson is the PDI coordinator for the LTAR network. Typically, when a data management task is identified, the project coordinator will develop a work request. This request will include a general description of the data management task, a data frontline manager, a group of scientists who are experts in this area and have an interest in the task, and a few other task-specific questions. This work request is submitted to the PDI board. If approved, the research committee will be formed and called to order under the guidance of the data manager who is working under the project coordinator. For the majority of these committees, we're hoping to complete the committee work in less than 3 months. Now, this is highly dependent on the committee and the PDI team workload. These committees will be charged with refining the criteria for the data management product. Once the initial criteria are established, this becomes an iterative process where the PDI team develops a solution based on the committee's criteria. The committee evaluates the solutions and provides feedback. The tech team will then rework the solution based on the new feedback. This process continues until the committee is satisfied with the tech team's solution. At this point, the solution is released and the committee is dissolved. Next, we have the PDI technology team. You'll be hearing from them in session 2. Then we have the PDI regional labs effort. Currently, we're developing a pilot regional manure, plant, soil, and water laboratory focused on common sample analysis. Kyle Elkin will discuss this in session 4. Next, we have the project assurance team. This team has not been formally developed yet. We're hoping to do so early this next fall. The PDI board includes Darren Harmel, Jim Eppolito, our moderator today, Jayoung Sun, Marlon Eve, Pete Kleiman, Sarah Bebout, and myself. Our current PDI coordinators are Kimberly Watson and Greg Wilson. This is a chart put together by Cindy Parr to illustrate the services provided by 5 of the data informatics platforms supported by ARS at a national level. The PDI platforms provide the following services: workspaces and analytical tools, data standardization, integration, and harmonization, and focused data discovery and access. The PDI and Ag Data Commons technology teams are working together to develop a seamless data pipeline between the PDI platforms and Ag Data Commons. Bruce will touch on this in session 2. As we build out the PDI DSI platform, we'll be working with the SciNet team to develop a means of running some of the models and decision support tools listed in the DSI platform on the SciNet high-performance computers. The goal is to integrate these agency-level resources to provide researchers the data management, processing, and curation services they need to develop the agricultural research innovations of today and tomorrow. Thank you for spending your afternoon with us to learn more about PDI.